Cool. Obligatory, yes, mic works. All right, cool. So hello, everyone. Welcome to my talk on driving organizational sustainability with platform engineering. So just a little bit about me before I continue on. So I was already introduced, but my name is Lesley. I'm currently a staff engineer at the New York Times. And more specifically, I'm focused on our election readiness efforts for the general election 2024, as well as observability. And as someone who is an engineering leader across all of the Times, I spend my time thinking about the function of platform engineering and how it can facilitate success across all of the Times. And ultimately, what that ends up looking like is coming from the perspective of enabling our department to work in a way that ensures long-term organizational success while enabling short-term growth opportunities. And so I'll start off by talking about what do we even mean when I say organizational sustainability. And more specifically, I define sustainability as the continuous practice of operating in a way that enables short-term growth opportunities while ensuring long-term success. So there's a lot to unpack there, so let's move forward. Now, first, sustainability is a continuous practice. So even if we spend a lot of upfront time thinking about how to ensure long-term sustainability, right, circumstances change often quickly, especially this year in tech. And so we need continuous avenues of ensuring long-term success. Secondly, enabling short-term growth opportunities. Sometimes those risky growth opportunities are what lead to our long-term success, right? The emergence of bundles of tools has become a really successful opportunity for some companies, including the Times, right? I'm sure at least some of us like Wordle or New York Times Cooking or Wirecutter, et cetera, right? So do we, right? And it was a revolutionary decision for us. And so we don't want to give those up, right? But putting on my reliability management hat, we also want to prepare for the risk of those opportunities, which leads us to the component of enabling long-term success. So we frequently see companies take for granted their core business, right, in the name of growth. But for every successful growth opportunity, most opportunities do fail, right? We don't like to admit that, but it's true. And so preparation for this type of risk is going to be essential. And so now that I've defined the goal, which is organizational sustainability, let's define the strategy, platform engineering. So as much as I hate repeating words on a slide, I'm going to do it if only for emphasis. So using my definition of platform engineering drives organizational sustainability by practicing sociotechnical principles that provide a community-driven support system for application developers using our shared platform architecture. And so these three components form the basis of what it means to provide a platform. And so one thing throughout this talk will be about how platform engineering can enable us to scale our applications to enable the growth that our businesses often demand. And as part of that, we'll need to ask us, when is the right moment to introduce this idea or framework of platform engineering? And so we frequently talk about scaling software, right? But what does it actually mean to scale an organization? And the answer is that ultimately our ability to scale our organization is directly tied to our ability to scale our applications. And when we think about scaling our software, right, we have to be intentional about addressing the inevitable complexity that comes with that growth. And so to address this complexity, we have to bring this intention into how our architecture can enable those needs. And so this is because complexity makes things so much harder, right? It makes things so much harder that we as a collective industry have evolved the ways that we build applications. So for example, right, the modular monolith has become an increasingly popular architecture style, especially as an intermediate step towards scaling our applications with distributed architecture patterns. And so just like we've evolved the way that we build applications to embrace new architectural patterns, like microservice architectures, we must evolve the delivery strategies that we use to build these new architectural patterns. And so if architectural patterns are a solution to the technical complexity of scaling our applications, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. And so to summarize this concisely, right, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. So we'll spend the rest of this talk decomposing each of these components even further, the principles that guide us, the community-driven support that enables application developers, and the architecture that we use along the way. And so first we have the principles that guide the rest of our platform. And so having focused on reliability management, the principles that we review will be heavily influenced by DevOps, particularly because DevOps principles takes a strong consideration for both the technical and social components of what it means to build and operate software. And so let's head into those principles. And so some of us might have heard of the COMS framework, which is basically a framework of principles that should be at the core of DevOps organizations. And so now, while all three could be applicable here, we're just going to focus on three, more specifically culture, automation, and measurement. So starting off with culture, the COMS framework tells us that DevOps drives a culture of continuous improvement and reduces silos by intentionally sharing knowledge and feedback. And the same is true here for platform engineering, though I'll talk about this a little bit more directly by putting it in the context of community. And so in DevOps, right, we often talk about breaking down silos, and the way we do that is ultimately by sharing knowledge. And to share knowledge means to connect, right? Connection and communication are key for preventing the silos that hinder our ability to make continuous progress. And when we're talking about organizations, especially as they grow, right, the most effective way to manifest this type of culture is to think about how we can do it at scale. Because ultimately, right, the opposite of isolation is to be in community with other people. And the reason that that's so important is because more than anything else, learning is the most sustainable advantage. And so this quote is by Andrew Clay Schaefer, who is often known for being the co-founder of Puppet. And he recently said this in his talk on sociotechnical systems at DevOps Days Amsterdam. And the way I interpret this to mean is that because our industry is always changing, right, that's why we're at conferences like this, being able to keep up with this change is the biggest advantage that we can give ourselves. But to do that, right, learning needs to be part of our organization's DNA. And now, while I agree with him, I'd like to modify this a little bit to emphasize that communal learning is the most important sustainable advantage. Because while our individual growth is important, right, if this knowledge isn't being shared intentionally, we risk introducing singular points of knowledge. And so like our technical systems, right, humans are not supposed to be 100% reliable, and we shouldn't be putting anyone in the position to be those singular points of knowledge. And so ultimately, right, this is how the silos are created. And this is ultimately how silos become an organizational pattern that hinders our sustainability. And so in other words, right, communal learning is what provides the knowledge redundancy needed to sustain both ourselves and the business. Next, we have automation, which improves our software delivery process by reducing human error, improving our efficiency, and enabling faster delivery. And so this means thinking critically about the type of work that doesn't actually require business-specific knowledge, and figuring out whether that can be consolidated into software that's managed primarily by platform engineers. And the type of software that doesn't require business-specific knowledge and is work that we can do to reduce the cognitive load that product engineers often have to indulge in by managing all aspects of their software. And so that type of work, right, is often one that is repeatable or manual, which is what SRE might refer to as toil, and what product engineers might refer to as boilerplate software. Another aspect of platform engineering is how we should be explicit about improving efficiency by leaning into solutions built by third parties, whether that's through vendor solutions or open source ones. And the reason for this is because we need to reduce our own cognitive load and maintenance burden just as much as we need to for product engineers. And lastly, we have measurement. And so first, let's talk about the function of measurement, right, which is ultimately to have feedback loops for whether our work is actually having its intended impact. And these feedback loops consist of both quantitative and qualitative feedback loops for continuous improvement. And the way that this principle connects to sustainability is by, again, eliminating the work spent on work that doesn't ultimately lead to those business goals. And so, for example, right, if a tool that we spent a lot of time on doesn't actually serve our product engineering users, which leads to lack of adoption, right? Now that time that we spent building those tools has gone to waste, and that time could have gone towards actually serving our product engineering or our product end users. And so we end up missing the ultimate goal, right, of building applications that age well with evolving product needs. And so, in other words, right, these feedback loops keep us on the right path towards making sure that we're enabling continuous improvement. And so now that we've defined our principles, let's shift over to talking about the support strategies for application developers integrating with our platform. And so we'll speak to both scalable and flexible strategies and put it in the context with how we measure success, consolidate efforts, and cultivate a culture that values sustainability. And so the first is the most scalable strategy of all, which is to make building sustainable software easy. And so we'll deep dive into this more when we get to the next section about platform architectures. But just to set the stage for that, right, let's remember that sustainable organizations are tied directly to their ability to build sustainable software. And so I'm sure we've all worked with software that clearly wasn't built with much foresight, right? This is usually what we refer to as tech debt. And this is going to be inevitable, right? Tech debt is inevitable, but we can mitigate its risk by being intentional about and strategic about when we choose to inject tech debt. And so ultimately, right, tech debt should have a function, usually for the purpose of growth opportunities. And tools that aren't easy to integrate aren't the type of technical debt that typically pays off in the long term. And so it's especially our duty as platform engineers to build easy-to-use tools to minimize the time spent needing to support application developers. Now, that's not to say we shouldn't be willing to support developers, right? In fact, the opposite is true. Just because platform engineering is supposed to make domain boundaries clearer and decouple product development from the supportive tools that's often needed, doesn't mean that we get to stop talking to each other and working together. And so I know as engineers we have to have an aversion to social interaction, right? But people are supposed to interact with one another. And I think the pursuit to make everything self-service is often more harmful than it is helpful. What we really need to do is, again, be intentional about the right time to support and how we can leverage a culture of communal learning and support so that platform engineers are not the singular points of failure or knowledge that I mentioned earlier. And so not only does this alleviate some tension on us, but it enables us to be community-driven in the way that we support product engineers. And so we talked about measurement as a principle earlier, and an important measurement is the effectiveness is the adoption of our platform. And so what intention looks like here is ultimately defining the ways that we approach support and clearly communicating it to platform engineers so that we can avoid mismatched expectations that will ultimately degrade our trust between both teams. And so in the interest of time, I'll only provide one example of this, which is to provide an easy decision framework driven by the status of your tool. And so we don't have time to review, but feel free to take a picture if you like while I drink some water. All right, so a common pitfall for platform engineers is to take on too much platform integration work. And so like the last slide showed, there is room for that in the early experimental mode, but that's not scalable. And therefore, it's not sustainable. And nor are we even often the right people to even be doing that type of integration work. And so like an example here that's relatable is testing, right? Platform engineers can certainly create testing frameworks or recommend the ones to use, right? But we can't be the one that are writing actual unit tests for a service. That requires domain knowledge. And luckily, if we're doing our jobs right, the time that we save from product engineers can just be reallocated to writing those robust unit tests. And lastly, driving a sustainable culture. So sustainability doesn't just apply to software, it applies to people. And the two are very closely tied. And so referencing Accelerate, which is a common book in the DevOps space, it talks about self-sustainability and the different types of burnout to look out for, whether that's physical or emotional, et cetera. And because platform engineering work naturally touches all, or many, if not all parts of our organization, right? We have a unique opportunity to show what it looks like to operate in a way that achieves excellence without sacrificing people along the way. And so our work is naturally collaborative and can impact so many parts of our organization. And so for me, what I try to do is drive this culture of intentionality with everything I do. And lastly, we have our platform architecture, which is the architecture that platform engineers are building to support application development. And again, the function of this architecture ties directly to the first support strategy that I talked about, which is to make building sustainable software easy by reasonably consolidating efforts and cognitive load. And so we've already talked through our high-level principles, but we'll review a few architectural principles or practices. And so the first is to embrace design-driven architecture as a core set of principles or practices. Intentionality should be an important attribute of the way that we build technology and collaborate with one another, right? And this intention should manifest in the way that we design platform systems, whether that's to use abstraction or modularity to make sure that we're separating different functional concerns. And so this principle can be broken down even further, but we'll omit that for now because we're going to talk about some design tensions in a few. And secondly, our architecture should be complementary to those of our users, right? Now, that doesn't mean we shouldn't try to anticipate developer needs. There's a lot of value in thinking about where our platform might be heading, right? But to the last principle on intentional design, right? We need to design with the future in mind, not necessarily build for it immediately, right? much in the same way that we might design our monolithic applications to be composable so that it enables us to decompose it in the future. And so when we prioritize our work, we should be driven by the needs, the actual needs of the application developers in our organization, whose architecture should be reflective of our paying end users. So that might mean that we prioritize different domains, more specific ones, right? Whether that's CI/CD or observability or runtime language support. That's why I'm focused on observability these days. But honestly, I don't expect that to always be the case. And so moving on. Sorry about that. And within those domains or problems that we're going to try to solve, right, we also need to build in a way that's responsive to evolving architecture and developer needs. And so, for example, right, if we want to improve the runtime experience of our developers, we should be prioritizing the languages that are actually used by them, not just the ones that we want to support. And ultimately, right, we're not here to tell other developers what to do. We're here to support them in what they need to do. And another reason that this is important is because our platform architecture can easily lead to what I would call platform chaos. So I really hate this slide because it's honestly, it triggers my fight or flight response. But like ultimately, right, this is not what we want, right? Like no one likes this, right? We don't want to live in a world where there's 10 tools for everything that you can do, right? And so this is something that we need to avoid, right? Unnecessary drift is painful. And so an overwhelming number of tools, especially custom ones, right, is not our goal. It is not the goal of platform engineering. And so tools should really just be enablers of our goal to build successful engineering organizations and businesses. And so instead, right, what we need to really be doing is be managers of chaos. And so the way that we do that is by aligning the components of our developer platform with specific domain use cases. And so this enables us to design our platforms so that we can see the similar benefits of concrete separations of concerns that we often see in end user facing architectures. And so this is where I'll take a moment to talk about a common pitfall in platform engineering, which is that platform engineering is not equal to infrastructure platforms. And so I'm going to repeat that again because this is something that really bothers me about platform engineering, actually, right? Platform engineering is not equal to infrastructure platforms. And I think this is a big part of why we see a lot of naive conversations in DevOps about it being dead in lieu of platform engineering. And this is because a lot of us are operating under the assumption that the only shared platform that companies need are ones related to or limited to infrastructure. But for example, right, we should also be thinking about how platforms can aid the service or feature development during the actual development or implementation phase. And so that might mean having language runtime platforms that support the development of standardized Node.js services, for example. And each of these can be decomposed even further, right? Though again, tying to pattern number 2, this decomposition should only happen if there's a genuine need for it. And so for example, right, if our organization decides to introduce a new standard language, then that's a good moment to actually decompose your runtime platform. And so in the infrastructure context, you might see that further broken up into domains like cloud infrastructure, CI/CD, observability. And so to complicate this even further though, there are even product platforms, right, which might refer to as specific end user product domains or a core platform. You might see this as like named core services at some companies. It is what it is, naming is hard. And so lastly, choosing boring technology. And so this ties back to when I spoke about not building tools from scratch. And we can also prevent that by making sure that we're not leaning into every cutting edge opportunity, right? So some years back, someone named Dan McKinley wrote this blog post that went tech viral called Choose Boring Technology. And he talked about this idea of innovation tokens and how we need to be intentional about where we spend innovation tokens. Right? So engineers, we love to play with new toys, right? But every proof of concept shouldn't be making it to production, right? And I acknowledge, again, this is tempting, right? Because CNCF, for example, is releasing tons of new standards and tools, and I totally understand why you want to understand them, right? But discovery and experimentation doesn't have to mean that we have to release it to production. All right? And one of the most seen as boring technologies is documentation. Right? This might be a hot take, but too many internal developer platforms can really just be replaced by best practices and standards documentation. And like, of course, that's not as exciting, right? But it's still work that enables us to learn and mature how we build technology at our companies. And even if months later or years later even, we decide that we do end up needing to build a new that was a Freudian slip, a new tool, right? It's still often not work that's wasted, right? Because it actually ends up being a pretty good start for defining requirements and design. And so I mentioned this earlier about some design tensions related to architecture best practices. And so next we'll review those tensions, including a framework for how to address the 4 primary tensions. And so first we have what I think is the hardest tension to balance, standardization versus flexibility. So the shared nature of a developer platform is an awesome opportunity to reduce the risk of drift, right? But we have to hold that in tension with the flexibility that developers might need, especially as our organization grows and our different technical needs grow with it. So for example, right now my organization is facing the consequences of building tens of services with an opinionated framework that has not aged well since. And so not only do we have to revisit how we approach runtime support, we also have to reconcile the tech that came from those decisions years ago. And that said, reflecting on where we went wrong, but what we're doing now is to engage with our users more. And so I started off this talk, right, by saying the opposite of isolation is community. And so now we're driving it from the approach of driving standards with actual teams and our communities of practice. So next we have the tension of simplicity and complexity. So as we respond to the needs of our users, complexity is going to become harder to manage, right? And that's because the architecture that supports them is often subject to change, right? Whether that's to begin using event-driven communication or client-rendered front ends. And so this becomes another area where we need to be intentional about. Like tech debt, right, complexity is going to be inevitable, but we can compartmentalize it somewhat by making sure that our developer-facing interfaces are simple. Which leads us to the most common source of complexity, which is integrations. And so we know the common design principle, right, of reducing coupling between services, and the same applies for our work. Integrations are high risk because avoiding coupling is incredibly difficult, right? And that's why it's a huge selling point for our vendors, because they take care of those integrations and now we don't have to think about it, right? That's what we're really paying for. And so speaking of vendors, remember the automation principle from earlier? And so even though I just spent some time talking through some design decisions for building platforms, I'm here to also say, like, give yourself permission to not build at all, right? The decision to build versus buy versus reuse should be our bread and butter. And deciding that we don't want to take on the burden of building and maintaining a new tool is a valid one, because as one of my brilliant mentors once said, right, every line of code that we write is a liability. And so code isn't the bread and butter of platform engineering, right? Research, design, and intentional and technical decisions are. And so engineering is a craft, right? And we should always be treating it as one. And so holding all these tensions in mind, let's talk through what I call the platform recipe. And so this is a reusable framework with 4 pillars. And these allow us to enable, compartmentalize, or communicate the trade-offs of the tensions that we just talked about. And so together, they ultimately make up our developer platform. And so we'll briefly review each of these and then provide some actual examples. I saw someone want to take a picture, go for it. I'll drink water. Oh, sorry, I went to the, sorry about that. All right. I know what I did. I'm using the wrong button, I'm sorry. Cool. All right, so first we have the parts of our architecture that provide standardization. So 2 examples of how we might see this manifest is through a template or opinionated frameworks. And so secondly, we have parts of our architecture that provide more flexibility. And so for example, we might design our framework to be more modular so that developers can pick and choose based off of their context. Thirdly, we have the parts of our architecture that compartmentalizes complexity through integration, since the first pillars reflect the simple interfaces that I mentioned earlier. And so this might be APIs that tie the first 2 pillars together, or plugin interfaces that developers use to ultimately, usually for us to provide visibility into the platform that we're actually providing them. And these tools that are often not used directly by product developers in their development are instead usually tools that we use to enable them in an automated way. So for example, right, the tools that pull our technologies together to support on-demand environments, right? Product engineers are certainly going to be using those, right? But the specific implementation details of what that looks like should be abstracted away from them. Lastly, we have the parts of our architecture that communicate our design and decisions along the way, whether that's API docs or decision records for when we decide to build, buy, or reuse. And so it might feel a little strange to have this be part of your architecture, but as I've emphasized throughout my talk, right, like touch points and communication between platform engineers and product engineers is going to be essential for our success. And so documentation is the first obvious one, with support channels as a complementary. And so there's also a potential need for automating certain aspects of how we support platform or product engineers, especially as we're scaling up the number of engineers that we're supporting. So for example, right, if you're primarily using Slack as your communication tool, integrations that consolidate the questions together can enable us to have more robust feedback loops for our actual software and being able to drive adoption successfully. And so in the integrations pillar, I mentioned plugins as an example to provide visibility of which tools we're providing. And so that's an essential question to answer because visibility is going to be needed to drive adoption. And so let's answer that question of how do we provide visibility into our architecture? So especially with the emergence of Backstage, which is an open source project created by Spotify, developer portals have become a way to provide centralized visibility into the developer platform ecosystem. And so the concept of a developer platform portal is a compelling one, right? It tells a story of what it means to develop software at your company. And so by providing a unified view, not only does our platform become visible, but it also facilitates visibility into other services that are using the portal. And so integrations are a crucial part of developer portals, but because it's a centralized entry point, right, we do need to consider the risk of a singular point of failure. And so this is why it embraces the idea of plugins, which are designed to be easily added or removed from the host application without total coupling. And so in other words, right, just as we saw in our principles, we see the similar benefits that we see with microservices by having concrete separations of concerns. So now that we've covered some of the fundamentals, we'll move on to more concrete examples that I've worked on in the past. So in the spirit of showing that platform engineering is not just about infrastructure, we'll walk through 3 examples that reflect the story I mentioned earlier, the story of what it means to develop software at your company. And so what that story ultimately looks like is around the feature development cycle. And so in the interest of time, I'm not going to run through each of these steps. All you really need to know is that this is the story that we're telling, the one around our feature development cycle. And the ones most relevant to us for today, or generally, is the development, production readiness, and delivery stages. So those are the ones that we're going to focus on today. So starting off with development, which supports the end-to-end product development cycle, particularly runtime and architecture needs. And so this phase usually manifests in language runtime platforms. And so today we'll review ones based off of Node.js, since that's what I've done in the past. So for the first part of our recipe, we embrace standardization through runtime language supports, runtime language templates, rather, which minimize repeatable or boilerplate code by centralizing it into a template. And so what this looks like practically might be a simple server file like this. This template not only provides a reusable file, but it also acts as a standardization technique by including our organizational framework of choice, which in this case is Express. And so from this, right, developers will only need to modify the parts of this template that require service context, which I highlighted here. And so over time, we could also extend this template to include standards for other tools and dependencies like package managers, linters, testing frameworks, et cetera, which can be reflected in like JSON config files. And when beginning to build out these templates, just make sure to start small and build your way out. Rushing into their development can easily lead us towards a path of building a developer story that doesn't actually serve the needs of our product engineering users. So alternatively, you might decide to build a runtime framework that codifies our organizational standards. And so you can imagine, right, that as your organization grows its standards, that server file might be quickly overwhelming, right? For example, right, if we want to extend our functionality to include middleware to standardize how we write APIs, And as we add more and more of this code to the template, right, it's going to become impossible for developers to even know what are we providing them. And so, sure, comments can help, right? But there's a reason that we use abstractions in software engineering. And so in an effort to keep those templates simple, right, we can abstract the details away and replace the express code with our own framework. And so here's what that package code might end up looking like, as well as a simpler server file that we'd now be providing. And so, of course, there's many downsides to this, right? This is a fairly large dependency introduction. We have to maintain this code for years, and it's a commitment that we can't be making lightly. And it requires a huge amount of intentional design. But it addresses drift a lot more effectively, right? Because templates are easier to change versus frameworks actually abstract implementation from our interfaces. And so that's the part that really makes a difference between whether your framework ends up being a sustainable solution, right? So the question you should be asking yourself, is the implementation of your framework genuinely abstracted from its interface? Because that abstraction is what enables us to iterate on unforeseen pain points which are inevitable and avoid breaking changes or deprecations altogether. And so I've seen frameworks primarily work for organizations that adopt platform engineering somewhat on the earlier side, more specifically during the transition period where we've decided our monolithic application is no longer working for us, and that decomposition needs to happen. And this is because once you're already down the distributed systems journey, right, addressing drift with a framework is really hard to justify to service owners. Because at this point, right, the service was probably already built in a really opinionated way. And so reconciling the drift in software and people's opinions is often a really tedious process. But if we start building out a platform before we're too down that distributed systems rabbit hole, it can actually set us up well for successfully decomposing a monolith. And this is because the repeatable tasks like making our services observable that we need to do for each of the services can just be abstracted into a framework and used centrally. And now when frameworks and templates aren't the right path forward for your organization's needs, but you do want to provide some flexible options, runtime packages are a great tool in our recipe. And so here we still have a lot of decisions to make, right, including where on the spectrum of flexible we want this to be, since it's not a binary attribute. And these are still avenues where we can inject standardization. And so to ground this into reality a little bit, we might have this very naive function in a package, right? This header might indicate something related to authentication and we want to have a standard for. And in this case, it's just we want some value to be uppercase. And so while this function is opinionated, unlike a template or a runtime template, right, the functionality is opt-in, right? Meaning that while we want to incentivize developers to use it, we can't actually require them to. So an additional benefit of modules is that should you ever revisit the possibility of building a centralized framework, you already have some of the building blocks that you can use to assemble that ultimate framework. And so for organizations that are outside of that initial transitionary period between monolith and distributed architectures, building modules is a great first step when adopting platform engineering because it allows us to incrementally build for the needs of our developers without investing a huge amount of time that frameworks often require. Now, let's move on to the next pillar of our recipe, which are integrations and plugins. And so extending our example, as our organization grows and our architecture evolves with it, so might the number of our packages, right? And so this was the second design principle from architecture principle from earlier. And so developers are going to need visibility into these different packages. So naturally, we'll decide to integrate with a package manager or repository manager, which should be managed centrally so that it has clear ownership and so that it doesn't become bloated with extra artifacts that aren't necessary. And so conveniently, right, there might even be a plugin available for your developer portal so that it's even more visible. And along the way, right, we're going to need to document our work so that our users can use our tools smoothly. And so combining this with the second principle from earlier, right, finding ways to automate this will make our lives easier and set our docs up to be less stale. And so for Node.js, this might mean integrating with TypeDoc to automatically generate them, which then you can plug into the developer portal to render documentation there. Next, we'll focus on platform use cases related to infrastructure runtimes. And more specifically, we'll focus on container runtime experiences. And so reflecting back on our 4 pillars, we embrace standardization here, which is the first part of our recipe, through base templates or images, which minimize repeatable code or config by centralizing it into a version template or image. And here versioning is crucial, especially for templates, because it's very easy to fall back into the trap of drift. Now, when these two options aren't the right path forward, but we still want to provide more flexible options, standard image artifacts are a great tool in our recipe as well. And again here, right, we have plenty of decisions to make, including where on the spectrum of flexible versus standard do we want to be, right? And also whether we want to require them or recommend them to our users. So next we have the integrations pillar, which represent either the integrations between components within the same platform or integrations between multiple platforms, right? So for example here, what this might look like is template generators for Docker file or Docker Compose files versus the integrations between a container runtime platform and a Kubernetes platform. And lastly, all these different components and decisions can quickly get overwhelming, even when we're designing them with a lot of intent. And so not only do these decisions need to be reflected somewhere, we need to understand that infrastructure incidents are ours too, and that the process of incident management should be one that fosters collaboration and knowledge sharing, which was a principle that we mentioned earlier on. And so what that looks like can be a little bit tricky depending on your whether you have an SRE org or not, and their specific operating model. But regardless of organizational structure, right, driving clarity over what incident support looks like is crucial to avoiding broken trust between platform and product engineers. And so part of that is making sure that platform or product engineers are set up to effectively differentiate when a production issue is due to infrastructure versus application ones. And lastly, we have a more specific domain use case for a platform, which is observability. And so when it comes to production readiness support in general, right, this work often tends to build off of existing platforms. And so this is what you're going to see today. And so going back to the build, buy versus reuse tension I mentioned earlier, let's say that we use the OpenTelemetry standard after considering the trade-offs of building our own standard, God help us if we do that, using one from open source or using a vendor-specific one. And so given this decision, we choose to embrace standardization further by adding a new config to a values file to support the standard. An important thing here to note is that this technical decision reuses a technical decision made by our infrastructure platform teams, and this is to avoid any unnecessary technical drift. And so really what we're doing now is extending their platform to support reliability and observability needs. And so the impact of this is that developers don't have to worry about managing the config needed to use a theoretical OpenTelemetry collector that we decided to provide. And so instead, now they can focus on instrumenting their applications for telemetry that requires service context. And so usually what this means is enabling them to focus on application instrumentation instead of infrastructure needs. And so switching gears into more flexible offerings, we choose to extend our runtime platform to include modules that provide features relevant to telemetry collection. And so this might mean providing an optional middleware function to enable telemetry collection. So in this very naive example, we see a similar tension as earlier where we standardize the key of an attribute, but provide the flexibility of managing the value through an environment variable. Also, none of this code is from the New York Times. I don't want to get in trouble. And so now I mentioned that our work needs to align with the needs of our product engineering users. And so let's say that our product has become really successful, right? We are solidly in the distributed architecture space for better or for worse. And now some of our product teams have new technical requirements that require them to be very cautious about any performance implications. And so they need strong concurrency support as well. And so our organization decides to introduce a new standard language into our organization, Go. And so this does make our lives as platform engineers a lot more difficult, perhaps. Right now we have to support another runtime language, but we shouldn't be meeting them with resistance, right? As peers, we can give them feedback, right? Like perhaps the decision does need a lot of pushback, but being dogmatic about our targeted paths isn't a recipe for success either. And this is ultimately, right, we're going to start to have to think about Go development, right? And so using my observability example, that means we need to think about what telemetry collection looks like for Go. And so we already use OpenTelemetry, so we reuse that decision for the sake of consistency, except now we come across this, right? Like work in progress, that sucks, right? So what do, right? We know telemetry collection is important, right? Like how else are we going to debug our systems? And so do we rely on older methods of collection, manual instrumentation, vendor-specific agent, et cetera? And that's one valid conclusion, and if I'm being honest, that's the most practical. But I'm still going to take an opportunity to share out the kind of change I want to see in the world, so bear with me. So I'm going to give a little bit of a nod to open source. And so our second principle talked about the role of automation in our work and how one form of that is to reduce the duplicate work that often happens in engineering, right? And we're specifically offered the solution of deciding when to build, buy, or reuse existing open source solutions. And part of the reason for that is not only because we'll end up spending unnecessary time reinventing the wheel, but also because we have to admit to ourselves, right, that oftentimes other people are going to do this better than us. And admitting that doesn't make us any less of an engineer, right? In fact, I think it shows humility and appreciation for the work of our peers. And it provides another opportunity for us to learn from one another, right? We can't be experts at everything. And so engineering, I think, is also an underrated way to build community, and it doesn't have to be isolated to just your company. And so this is something I'm actively looking to do, is for us to engage in open source more, especially since the New York Times has traditionally been pretty good about that. But unfortunately, we've kind of lost our spirit in that, so pray for me that I'm successful. And so bringing me back to my observability example, we know that there are already really smart people out there, right? But that also there's clearly so much to learn. And so community-driven support has been a central theme here, right? And so we don't want to learn and build in silos. And so learn and contribute to the communities that are already doing this work. Because as much as the sustainability of our organization is tied to our ability to build sustainable software, the sustainability of our organization is about our industry's collective ability to learn together and make progress together. And so moving on to the third part of our recipe, we choose to extend our CI/CD pipeline platform integrations to include application metrics that will allow us to automate rollbacks that minimize the risk of change. And again, this is an example of how reliability management work is often complementary to other existing platforms. And lastly, best practices and guidance docs. Especially because observability is such a full stack problem, everyone is going to need to think about observability and telemetry collection specifically. And so we need to leverage that collective knowledge and put it in context with our work, and then communicate what that looks like to other engineers so that we're all aligned in how we approach this problem space. All right, so now that we've walked through the three components of our platform, let's put this all together by framing it through the lens of the feature development cycle from earlier. And so more specifically, we'll approach this from the lens of the life cycle of a service, focusing on the flow that reflects what it looks like to build a new service at our organization. And so starting from the left here, let's say as a product engineer, we're building a new service, a new backend service in an organization with a fairly mature platform, which is why you'll see some components here that we didn't mention before. And so to get started, you as a product engineer, enter the developer portal integrated with an artifact manager, select a bundled standardized service template, enter details like service name, and then an API integration that platform engineering owns generates the service using an integration with GitHub. And so now you're ready to develop your service, right? Depending on your development needs, you utilize even more modules or use framework features. And from there, you'll continue on to use GitHub, whether either directly, but now you can also do that through your developer portal until the PR approval process is done. And from there, right, you're going to enter the more delivery-focused portion of our platform. And so that bundled service template that we use to generate the service also includes config templates that the CI stage can use to build, test, and perform static code analyses, et cetera. And so now we only have to worry about choosing good values and modifying the values YAML file. And since our portal includes a drone integration, developers can easily gain visibility into each of the steps, which is especially useful for when things fail. And as a best practice for platform engineers here, we should be very intentional about making it clear when CI/CD pipelines are failing because of our tools versus when they're failing because of an application bug. So if the CI stage passes, a CI integration then pushes build artifacts that were generated in the CI stage, providing access for the rest of the stages of our pipeline. And again, the developer portal provides visibility through this, through our artifact repo manager and drone integrations. Now, those artifacts would be used during continuous deployment as well to perform things like infrastructure management, pre-production testing, et cetera. And so using GitHub or its portal integration, we move on to the tasks related to release management, like approvals and release tagging and release documentation, etc. And so after successful testing and approvals, the service is deployed to production using similar mechanisms as automatic rollback features that we mentioned in the production readiness portion. And finally, we've concluded the delivery process and head into maintenance mode, which is supported by the observability tools we use to observe and monitor our systems. All right, breeze through that section, but before we conclude, I want to bring us back to where we began. And so just to wrap this up, I've made parallels between DevOps and platform engineering throughout this talk. And I hope it's obvious more than anything else, perhaps, how important DevOps has been for this discipline, much in the same way that it has been for site reliability engineering. Right? Our systems are complicated because people are complicated. And just like architecture design, this type of culture doesn't just happen, it requires a lot of intent. And so the most compelling part of DevOps is ultimately the way that it transforms our cultures to be one that fosters exactly that, intent. And so I started off this talk by saying that platform engineering is a solution to building sustainable organizations, but perhaps the solution that we all really need is actually just intent. Thank you.